Welcome back, everybody. Today we're going to tackle the second part of lesson 4.2, do some more proving identities. And here what I have for you are just two more types of proofs we can do. So let's get going with that right away. Let's rock and roll here. Alright, I'm going to hide my face the rest of the way here just to give myself more room to work. Hopefully I left enough space in the note guide. Disclaimer, today's stuff is a little bit gnarly, but it'll be okay. We're going to get through it. Problem 4, I'm going to say, is adding fractions again, adding uglier fractions. Okay, again, we've got an identity to prove with some ugly looking fractions on the left. Okay, no tricks about this one. We'll start on the left side. That's the ugly side. So I'm going to rewrite this. So my start, sine of x over 1 plus cosine x. All right, plus 1 plus cosine x over sine x. Okay, I want to prove y that's equal to this 2 cosecant x. Okay, now just like with our simpler fractions, if I want to add these together, I need a common denominator. And that common denominator is going to be made up of a 1 plus cosine x times the sine of x. Okay, so I need to give each of these fractions what their denominator is missing. The first fraction doesn't have that sine x on bottom. So I'm going to multiply by top and bottom by sine of x. And second fraction is missing the 1 plus cosine x, so I'm going to multiply top and bottom by 1 plus cosine x. Okay, pay attention, make sure you don't do that backwards. Okay, you need to give the fraction what is missing if I want to put these together. All right, let's turn this into one fraction. I'm going to combine everything all in one step into a single fraction because, like we said, we will have a common denominator here, a sine of x times 1 plus cosine x. So multiplying through sine times sine, we have a sine squared x. Okay, and then in my other denominator, I have two binomials being multiplied together. So I can kind of organize this by doing the FOIL method. We'll go first, 1 plus 1. Sorry, 1 times 1 is just plus a 1. Okay, outer, 1 times cosine x, we'll say is plus cosine x. Making a mess here, but oh well. Inner, cosine x times 1 is plus another cosine x. And then last, cosine x times cosine x, we'll say is plus cosine squared x. Okay, that's going to be my numerator, so I'm going to have all of this over my common denominator, sine x times 1 plus cosine x. And notice I'm leaving the denominator in factored form. Okay, reason for that is eventually I want to combine all this stuff and do some factoring. I want to reduce things. And if I did distribute this, I could just factor it again, but typically on a adding fractions question, you're just going to leave your denominator in factored form. Okay, let's clean this up here. Now I'm going to show more steps than you necessarily have to show on a test or a quiz. Numerator, I have my sine squared x. And then I'm going to write next this cosine squared x. Just going to rearrange things. And we'll say plus 1. And then we have 2 cosine x's, so I'm going to say plus 2 cosine x. All right, over the same common denominator, sine x times 1 plus cosine x. Now I guess pausing here for a second, I'm thinking some of you folks want to start canceling things out like the cosines or the sines. Now since my numerator is not in factored form, it's not written in parentheses, I can't do any canceling yet. Okay, so I want to combine things and reduce them up top, then factor before I can cancel top and bottom. Okay, the trick for this problem is recognizing we have a Pythagorean identity. Sine squared x plus cosine squared x, that's our original Pythagorean identity. That's just a 1. I'm going to rewrite that in red here. So what I have then is 1 plus my other 1 plus 2 cosine x all divided by sine x times 1 plus cosine x. Okay, so I can combine my 1's obviously, and I'm going to move this up top here. So 1 plus 1 is 2. All right, 2 plus 2 cosine x over the same sine x times 1 plus cosine x. Okay, we're getting there. Now the other trick with this one is recognizing I can factor my numerator. Okay, since both terms here, the 2 and the 2 cosine x have a 2 in it, I can factor that 2 out. I can go 2 times the quantity of 1 plus cosine x. All right, all over the same sine x times 1 plus cosine x. Okay, then finally at this point I can cancel. I'm finally in factored form. I have a factor of 1 plus cosine x on top, factor 1 plus cosine x on the bottom. Those can reduce. And we end up with a 2 over sine x. Okay, I'm shooting for a 2 cosecant x, and that's what I have. 1 over sine x is just cosecant, so 2 over sine x would just be a 2 cosecant x. All right, there we go. When I say ugly fractions, that's an example of what I mean. Okay, after you do a few of these, they really aren't too bad. You're going to see a lot of the same Pythagorean identity tricks, factoring tricks to cancel as you go through similar types of problems. Why don't you give part B a shot, pause the video, see what you can do with it, and then hit play either to check your answer or to get some help to get you unstuck if you get stuck. All right, part B, another ugly fraction proof. This one's going to work out pretty similar. Again, clearly, left side's the ugly side. So I'm going to start with that. Secant x over tangent x minus tangent x over 1 plus secant x. Okay, we need a common denominator. That common denominator is going to be tangent x times 1 plus secant x. First fraction's missing the 1 plus secant. So we'll multiply by that on top and bottom. Second fraction's missing the tangent, so we'll multiply by tangent x on top and bottom. And let's figure out what we're left with there. No foiling for this one. We do have to distribute. We'll go secant times the 1 and secant times the secant. So that's going to give me a secant x plus secant squared x. Okay, then for my second fraction, I'm going to have a minus tangent squared x. Oops, minus. That's all over the common denominator, and again, I'm going to leave that in factored form. We'll say tangent x times 1 plus secant x. Okay, and then here, when I have squared stuff plus square stuff minus, think Pythagorean identities. And it looks like I could do something with this secant squared minus tangent squared. If I pull up my identity with the tangent of the secant, it is that tangent squared x plus 1 is equal to secant squared x. Okay, what do I have here? I have a secant squared minus a tangent, so if I subtract tangent squared x from both sides of this equation, both sides of this identity, I get 1 is equal to secant squared x minus tangent squared x. Okay, so in other words, what I can do is I can replace this secant squared x minus tangent squared x with just a 1. So what I'm left with on top is secant x plus 1 times tangent x, or divided by, sorry, tangent x times 1 plus secant x. And then from here I can cancel. Okay, we're not in factored form, but basically I can think of this secant x plus 1 as just a factor on its own. Okay, so secant x plus 1, 1 plus secant x, same thing. They reduce, they cancel out. So what I have then is a 1 over tangent x, which we know is just cotangent x. And yep, that's what I'm shooting for. So I worked that other side. My proof is done. All right, and the last type of problem we're going to look at, I'm going to call the multiplying by conjugates type of proof. Okay, so prove the identity, and the reason I know this is a multiply by conjugates one is I have a single ugly fraction with a binomial 2 parts in the denominator. This won't work for everything with 2 parts in the denominator, but if we give it to you on the homework, if we give it to you on the test, that's going to be the way to approach this. So again, I know that it's a multiplying by conjugates question because on my ugly side of the problem, there is a binomial in the denominator. Okay, so we'll start with the left side, sine x over 1 plus cosine x. When I say multiply by the conjugate, what I'm going to do is I'm going to multiply top and bottom by the conjugate of my denominator, the 1 minus cosine x over 1 minus cosine x. Remember, conjugate meaning the same binomial, just switching the sign of the second term. Okay, and why would I want to do that? Well, let's show you. Let's take care of the numerator first. Okay, sine times 1 and sine times negative cosine will give me a sine x minus sine x cosine x. All right, over in the denominator, I do need to FOIL this. Okay, there's a trick to it. We'll remind you what that is. But if I go first, we have 1 times 1, which give me a 1. Outer 1 times negative cosine is a negative cosine. Inner cosine times 1 will be a positive cosine. And then last, cosine times negative cosine will be a negative cosine squared. Okay, and the reason we use the conjugate is things will cancel out, things will clean up. The inner and the outer multiplications from FOIL will always go away. So notice I have a positive cosine and a negative cosine, which will cancel. So that gives me a sine x minus sine x cosine x over 1 minus cosine squared x. And obviously you could skip directly to this step just by kind of canceling as you go. Okay, can't cancel cosines yet because my numerator is not factored. But the other thing that multiplying by a conjugate accomplishes for us is it sets things up for Pythagorean identities. It gives us stuff squared with plus and minus. Now I know that sine squared plus cosine squared equals 1. And that means that I can replace this 1 minus cosine squared with just a sine squared. Okay, I'm not going to show the scratch work here, but rearranging our original Pythagorean identity would give us that. So I can say sine x minus sine x cosine x over sine squared x. And again, I'm getting that sine squared x from a Pythagorean identity. Now what I can do is I can factor my numerator. I can factor the sine x out and rewrite that as sine x times 1 minus cosine x over the sine squared x. And now I can reduce the sine x and the squared piece will cancel. And I suppose I could have done that at this point just by canceling both these signs with the squared. I need to be able to do it in all the terms though. So what I have then is a 1 minus cosine x over sine x. Okay, how are we doing? Well, basically what we've done so far is we've taken the left side and flipped it upside down. Doesn't look like we've accomplished anything really, but let's say it's a lot easier to work with when that addition or subtraction is in the numerator as opposed to the denominator. I think there are 1 or 2 in the homework we actually stop at this point, but this one's going to keep going. I want to get it to the cosecant x minus cotangent x. At this point, I can just split my fraction up. I can rewrite this as a 1 over sine of x minus a cosine x over sine x. and 1 over sine x is the cosecant x we're looking for. Cosine over sine is a cotangent, so we have a minus cotangent x. And there we go. Now we're done. We got to the right side. So there's an example of a proof performed by multiplying by the conjugate. Okay, B is a similar type of problem. Why don't you take a minute, pause the video, give B a shot, and then hit play to check it over or get some help. All right, last one for the day. Again, I'm going to say multiplying by conjugates problem because I have my ugly 2-term denominator. Now this one I could actually start from either side of the equation, but let's stay consistent. Let's say that it is the ugliest when we have addition or subtraction in our denominator. So I'm going to take the tangent x over secant x minus 1. And I'm going to multiply that by the conjugate of the denominator on top and bottom. So that'd be a secant x plus 1 on top and bottom. Okay, let's multiply that out. And I'm not going to distribute in my numerator. I'll show you why. I'm going to say I have a tangent x times secant x plus 1. If I did distribute, I could always factor later. And in my denominator, I have a secant squared. And there'll be a secant x positive and a negative secant x. Those will cancel, and I'll have a minus 1. Okay, my denominator then, based on Pythagorean identities, I know that tangent squared x plus 1 equals secant squared x. If I subtract 1 from both sides, we get tangent squared x is equal to secant squared x minus 1. So I can replace that secant squared x with just the tangent squared. So tangent x times the quantity of secant x plus 1 over tangent squared x. And at this point I can cancel my tangent with the squared part of the tangent from the bottom. Okay, again, if I distributed things in the numerator, I could always factor again to cancel. And that's going to leave me with the secant x plus 1 over just the tangent x. Now I could keep going, keep rearranging that, maybe come up with something different, but I know I'm done because I got to the right side of the identity. I got to what I was trying to prove. Okay, that's how I know that's all I have to do here. All right, there you go. Some tough stuff today, so definitely make sure you're getting through the homework. Definitely make sure you're asking questions. Now, a big part of this assignment is going to be deciding what type of problem you're looking at. Okay, what's the plan of attack? What's the approach? So what I'd encourage you to do is as you're going through the homework, maybe even before you start doing any of the problems, decide, is this a adding fractions problem? Is this a splitting fractions? Is this a multiplied by the conjugate? Is it something else? Okay, I think once you decide what the approach is, these problems really aren't too bad. Okay, so start going to town on the homework, give it a shot, and like usual, if you need help, we're here to help you out. Let us know.